We're going to hear now Jun Rao. He's the co-founder of Confluent, the creator of Kafka. Hey, Jun.
Hey, Aaron. Hi. Thanks, guys.
The stage is yours.
All right. I'm going to share with you how the journey of moving from an open source project called Apache Kafka all the way to a commercial company, Confluent. So if you are new to this world, Apache Kafka is one of the most popular open source projects out there. It's used widely by hundreds of organizations across the globe and across industry, including some of the largest Fortune 500 companies. And if you look at the usage of this platform, the volume of data that's flowing through the system is pretty impressive. So how did that get started? Well, some of you may have heard that originally Apache Kafka was started at LinkedIn. So I was fortunate to be able to join LinkedIn at a time when LinkedIn had its fast growth. In the short period of 4 years when I was there, LinkedIn's business and number of people grew by a factor of 10. And if you look inside, what's really powering that fast growth of LinkedIn? It's all about LinkedIn's ability to leverage data to derive new insights from its user to build a better product. Today, a lot of companies talk about data-driven, being digital first, but what's unique about LinkedIn is it had a couple of important realizations that allowed it to have this deeper level of leverage of its data. And today I will share what these two realizations are with you. The first realization I want to share with you is LinkedIn has this realization that leveraging data in motion is a much more effective way than leveraging data at rest. Now, what do I mean by that? Well, traditionally, a lot of applications are built on those data at rest systems. So when something interesting in the world happens, those systems typically just record that event. But the leveraging or the usage of data typically happens a lot later and often it's through some batch jobs. So what LinkedIn realizes is that this is actually not the very effective way of leveraging data. What LinkedIn wanted to do is for all those applications to define what they want to do with the data, all those new events. Then when those new interesting events occur, those events will be automatically trigger those predefined actions. So by doing this, it allowed a much faster and more deeper way of leveraging data. Now, how does that help LinkedIn's business? Well, I'll just share with you some examples. If you look inside LinkedIn, it's actually composed with hundreds of those we call microservices. So some of the services, for example, are sending email digest about something interesting happened to a network. Could be job change, could be other things. We have like a recommendation system, which would recommend other LinkedIn members that are not in your connection yet, but you may be interested in connecting to. And a lot of recommendation, again, is based on new information such as job changes, educational changes, etc. And LinkedIn also has this search index, which allows you to search by name, by product, or by organization. So historically, a lot of those services are really built on those data at rest platforms. So when something interesting like a job change happened, this information doesn't get incorporated into those systems immediately. And it's through some cron jobs, either daily or weekly, those systems will be upgraded. Over time, what LinkedIn did is to change all those microservices to event-driven. So those systems will be constantly listening to those interesting events, and then they have defined how they want to act on those systems. With this new architecture, now if there's a new interesting event like a job change that occurs, this information will be immediately incorporated into those systems. So what the end result is, this actually provides a much better user experience for the end users for LinkedIn. Because for all those services, the information they provide to the user is much more timely, and the information is much more fresher and much relevant to the user. So this is the first realization I want to share with you, which is leveraging data in motion is actually a much effective way than leveraging data at rest. The second realization LinkedIn had is the need to leverage all its digitized information. Now, what are all digitized information LinkedIn had? Well, initially, LinkedIn mostly focused on what we call those transactional type of data. In the case of LinkedIn, these are your job history, your educational history, and your connection to other LinkedIn members. But over time, LinkedIn just realized there's actually a lot of other information that's not transactional in nature, but are equally useful. For example, if you clicked on a link at LinkedIn, if you typed in some keywords, right, in the search box, these are not transactional per se, but they carry a very strong intention for the user. So in terms of deriving new insights, these data are actually as useful as those transactional type of data. But if you look at the volume of those data, these data are easily 100 to 1,000 times bigger than those transactional type of data. So if you want to be a data-driven company, you can't say you'll be ignoring 99.9% of your data in a company. So that's the second realization LinkedIn had, which is the need to leverage all digitized information, both transactional type as well as those non-transactional type of data. With these two realizations, when LinkedIn looked back into the infrastructure that it had, so what are the infrastructure it can use to satisfy these two realizations, it just surprisingly realized around that time, there's actually no good existing system that can satisfy both needs. Around that time, there were two common types of data systems most places have been using. The first is various databases. But the main problem with database is it's really primarily designed as a data at rest system. It's not really designed for trigger actions when interesting things are happening in the world. The second type of infrastructure a lot of places have been using are all sorts of messaging systems. There are quite a few of those, both commercial ones as well as open source ones. While messaging systems are indeed setting the data in motion, they can trigger actions as they occur. But most of the traditional messaging systems, they are really designed for flowing through just a transactional type of data. And when you try to flow 100 to 1,000 times more data on those systems, a lot of those systems are not really designed and built for scale. So often they stop working. So when LinkedIn realized that there's no good existing systems for LinkedIn's need, that's when we started to build new system. That's how the first version of Kafka was built. In the first version of Kafka, what we want to do is to build a native cloud data in motion system that can truly scale. So we did a couple of things to make that happen. The first thing is we introduced this key data structure, which we call commit log. We use that as a journal essentially to concisely and efficiently represent those data so that we can deliver data in real time. The second thing we did is to really make that system a distributed and a scaled out system from ground up. So in a typical Kafka cluster, you will have lots of those brokers. And the commit log I mentioned earlier, in a typical Kafka cluster, you will have lots of those, thousands or maybe tens of thousands of those. And those commit logs will be evenly distributed among those brokers. And together, they can jointly use all the available computing resources, such as network, storage, CPU, to serve need for the user. Now, over time, if your business increases and you need more volume of data, it's also pretty easy to handle that because you can just add one or more of those brokers, and then the data will be flowing, will be again redistributed evenly across those brokers, and together they have more computing power that they can use. So this turns out to be a much more effective way to make the system scaled out. The first version of Kafka took us about 9 months to develop. And it also took us some additional time to really migrate all the existing infrastructure of LinkedIn to this new platform. But once this exercise is done, the benefit of Kafka within LinkedIn is pretty obvious. What we have achieved is what we call data democracy. Because in the early days of LinkedIn, if you are a data engineer, you are a product manager, you want to try some new ideas, your biggest challenge is you don't know how to get all the data you need for your experiment, because the data at LinkedIn are spread into lots of like siloed systems. Some of them in some traditional databases, some of them are in some key value stores, some of them are in some ad hoc homegrown systems. And all of the systems are storing data in different formats. they have different APIs, and not everybody is like available in real time. So it's very hard for you to try some new ideas. Once we have upgraded LinkedIn's data pipeline to this new infrastructure, what we have is all the data at LinkedIn are now integrated through Kafka. And then the data will be available in motion. So which means if you want the data, all you have to do is to make a subscription to the subset data you want from this platform, and all the data will be flowing to you in real time under the same API with the same format. So now if you want to try some new innovation at LinkedIn, you don't really need to ask anyone. You just need to make a subscription to this Kafka system, and you will get your data. So with this new architecture, it completely accelerated the pace of how LinkedIn makes innovation. Another thing that quickly happened after the first version of Kafka is LinkedIn decided to donate Kafka to Apache Foundation. This is like a third-party, non-profit, open source platform. So this helped us in two significant ways. The first thing is it really helped the adoption of Kafka in major enterprises, in mainstream enterprises, because a lot of enterprises, they have used various other products from Apache Foundation before. And then once Kafka become part of the Apache family, they felt that this is a project that will stick there for a long time and they won't go away. So we see a lot of enterprises from various industries starting using Kafka once Kafka is part of Apache. The second thing is it really helped consolidate the developer community. So what we have seen is developers from all over the world start contributing to the platform by submitting improvements to the main code base, the documentation, answering questions, and building tools around this platform. So seeing the growth of this platform and the usage across the enterprise, we started a commercial company called Confluent in 2014. At Confluent, our mission is really to make this data in motion platform available to all enterprises across industry, across the globe. We realized that even though there's the core technology of Kafka is open source, but there's still a lot of things that we can do to make the consumption and the usage of this platform much easier for our developers. And I will just share you what are some of the other things we did at Confluent to make that happen. So what we are doing at Confluent are centered around three big themes. The first thing we are doing is really to help make our platform more complete. Because if you are a typical enterprise, right, you want to use a new technology, often you will need to think about how to monitor and operate this platform, and how do you add security, right, to private red access control. How do you do things like data governance? Today, I'm just talk about two things in specific that we did to make this platform more complete. The first thing I want to talk about is data integration. Because if you are a company that's like LinkedIn with a little bit history, you will find yourself in a situation that within your enterprise, you have lots of your data is stored in lots of siloed systems. You may have various databases, you may have various queuing systems, maybe file systems where you have been accumulating your data over time. To really make that data in motion platform useful, the first thing you have to do is to have all the data in those siloed systems extracted out and let them flow through this new platform. And similarly, once the data is in Kafka, often I think you want to have an automated way to have the data flow into the data sinks you have already, whether it's a search engine, a data lake, and other things. So what we did is we created the new framework called Connect. And at Confluent, over time, we have built hundreds of those different connectors that covers all those common data sources and data sinks. Now, if you want to do this type of data integration with your company, chances are you don't need to write any custom code, because all you have to do is to download some of those connectors and then configure them, and the data will be flowing through all those systems into Kafka and into those data destinations. So this is the first thing we did to make data integration easier. The second thing what we did to make the platform more complete is to help developers with the data processing part. So once the data is stored in Kafka, we have seen a lot of event-driven microservices being built on top of this platform. And if you look inside what those microservices are doing, they have some very common patterns, because a lot of those applications, what they want to do is to take the original data as feeds, but transform them into a different view and derive a new view of that. And that view allows the application to derive insights from the data much easier. As part of this process, often they want to transform the data in some ways. Maybe they want to convert the data from one format to another. Maybe they want to do some filtering, projection. They may want to do some data enrichment, right, by bringing some reference data into the event stream. They may also want to do some aggregation, over some time windows. So to make the developing of those event-driven applications easier, we are adding two frameworks for those continuous data processing. The first thing we added is a Java library, which we call Kafka Stream. So with this library, if you're a Java developer, you can use some of the higher level abstract to define some of the common processing patterns, like filtering, projection, much easier. The second thing framework what we added is from Confluent that we called KSQLDB. So this is a framework that provides a more declarative way for specifying this kind of common processing. And in this case, even if you are not a core Java developer, as long as you're familiar with SQL, you can use some of the SQL-like syntax to define this continuous real-time processing to build those event-driven applications. So this is the second thing we did to make our platform more complete. Another big area that we are investing to make our platform more useful is the portability. We want to make our platform available everywhere where our users want to have the system deployed. We are at a time where a lot of enterprises are migrating from the on-prem platform into the cloud. And when they are in the cloud, often they are thinking about multi-cloud strategies, either because they want to consider for merger and acquisition opportunities, or they want to use the best breed of services. So that's another area we want to make sure, no matter which environment people want to develop this platform, they will have good access for that. We started with a Confluent platform where we are truly offering a software deployment, but our user have to take the software and then deploy it and operate it. But starting from 4 years ago, we started offering a SaaS service called Confluent Cloud. It's available not only just in one cloud, but it's available in all the three major public clouds. So why did we do that? We feel that making a distributed system like Kafka available as a SaaS service is the best way of developing the software. Because by taking over as the operator of the system, we can take over those common things like upgrading the software, doing class expansion, balancing the system that we do on a daily basis. This will free the developers of our customers so that they can focus on their core business, so that they can build those new event-driven applications just by simply using this SaaS service. So by having our software available, both delivered as a software so they can do it on-prem, and also make that available as a SaaS service, we believe we can make our platform truly portable, no matter where you are. The last area I want to talk about is cloud native. We believe that by making the software cloud native and then change that architecture so that it can leverage the cloud resources more efficiently, we can truly build a much better SaaS service. Because the cloud platform is different fundamentally from the on-prem world. In the on-prem world, you pay for the hardware once and you can sort of use it for free forever. But the cloud is different because typically you pay for what you use. So that's why I think by using the cloud resources more judiciously, I think you can make a true difference for your SaaS offering. So here, I'm just going to give you one example what we did in Confluent to make the system, the architecture more cloud native and its implication. If you're familiar with Kafka, you will know this is how Kafka stores its data now. So each of the broker will have some local storage, and all the data, those data stored in those commit log, are spread evenly among the brokers, and they will be stored in the locally attached storage. Now, what are the issues with this architecture, especially in the context of cloud? Well, the first issue, potential issue, is in terms of cost, because Kafka is redesigned for real-time system, and we really need to have this fast type storage to store the most recent data, right? Because we want to deliver this low latency experience to our user. But that means for a lot of the historical data that people want to keep in Kafka, you also have to use the same type of higher cost storage system. The second potential issue is on elasticity, because now, since you have the storage coupled with the computation of the broker, now you can't scale them independently. For example, if you are running out of local storage, the only thing you can do is to add more brokers. But that just means you are overpaying for the computing resources for those brokers. So what we did at Confluent to make this more cloud native is to introduce a new type of storage, which we call infinite storage. Under the cover, what we did is to introduce two types of tiered storage within a broker. We still maintain a local storage, but that's really used for storing a small amount local hot set data. For the vast majority of historical data, we can now archive them into a remote object store, and then we only keep the references locally. Now, what's the benefit of this new architecture that's now more integrated with the cloud? Well, in terms of cost, now we only need to use the local storage, the fast local storage, for a small portion of the local hot data. The vast majority can be stored in those remote object store. That's much cheaper. In terms of elasticity, now we have truly decoupled the storage need from the computation need in a broker, which means the storage need and the computation need can now be scaled independently. Now, if you do need to scale the broker to add more brokers for the computation need, now you can do things like moving the data across brokers much more effectively, because now it's only the local portion of the data that needs to be physically copied. The vast majority of remote data, you can just leave them untouched. With this new cloud native architecture, we also achieved another thing, which is also important, which is we are now truly allow the data in Kafka to be stored for as long as you want. So this is important because gradually what we are seeing is in a lot of places, Kafka is becoming the first place where all the data within a company are integrated. So by keeping the data for as long as those applications need, we're providing the capability for Kafka to be truly used as a source truth. So it's not only useful just for the real-time part, but if you want to use that as a source truth for some historic access, we can provide a storage for you in an economical way. Now, how are people using this platform with all the capability we are using? I want to share with you one particular usage, and this is about a fintech usage. This is about Royal Bank of Canada, or RBC. If you are not familiar with RBC, this is actually one of the largest banks in Canada. They started a Kafka journey about 4 years ago. What they wanted to do in RBC is they want to use Kafka to solve the data integration problem. Because around that time, the biggest problem RBC had is they have lots of siloed data stacks. Because if you are a customer with RBC, you typically will have multiple relationships with the bank, because you may have a bank account, right? You may have a credit card, you may have a loan, you may have a life insurance policy. So each of these relationships is handled by a separate line of business, and each of them has its own infrastructure of storing data, and they seldom share the data among themselves. So what RBC did with Kafka is to have each of those line of business, there are about 15 of them, have their data extracted and integrated with Kafka. And from there, they build a real-time system that can integrate all the data together and make that available to all their 10,000 salespeople. Now, if one of the salespeople need to engage with their customers, their job is much easier, because in real time, they will have this holistic view of all the relationship the bank had with the customer. So over time, this platform has been evolved to 50 other applications, ranging from better user experience all the way to real-time fraud detection. As you can see, this is actually just one of the example how making the data in motion and then make the data available in real time can truly transform the core business of a customer. Just to conclude, we are at an exciting time in the enterprise space. We are seeing a lot of enterprises are going through their digital transformation. As part of this process, what they need to have is to have more and more information digitized and to have more and more those information to be utilized as soon as possible in real time. So what we are seeing is people are starting to build new applications based on those event-driven architecture using this data in motion platform. And we believe this is a pretty transforming technology. And giving it time, I think we will see more and more of those applications being used in this system so that they can build the next-gen applications that provide much better and effective user experience. And with that, I want to encourage you to look into your areas to see if there's anything you can do to leverage this new data in motion platform. With that, yeah, thanks everyone for listening, and I'd be happy to take some questions.
Thank you very much, Jun. Is it working? Yes. Thanks, Jun, for joining us so early in the morning. Well, definitely Kafka is a big part of Wix's infrastructure, as we saw in the keynote today, like 66 billion messages daily that we're moving. We don't have a lot of time for questions, so I'm just going to ask you one. How was the internal adoption of new technology happened in LinkedIn when you just started Kafka? Because you have the industry standard and now you invented something new.
Yeah, I think it wasn't easy. I think because around that time, LinkedIn already had hundreds of those microservices, right? So changing the core infrastructure takes time and requires a lot of coordination among the different groups. But what we did is I think LinkedIn just realized, I think by making the data or integrating in real time and make that available to the application, that's a truly a critical requirement for the core business, because the core business of LinkedIn is really to make this data available, right, to all its applications and its services as soon as possible and be able to leverage that as soon as possible. So once LinkedIn realized that particular need, which is this infrastructure is truly needed for its core business, then it's easier to convince the company to move together. So, and after that, I think we also demonstrated through our earlier prototype that this is actually a new system that truly can solve the problem LinkedIn had. Then over time, we just coordinate through different engineering teams and to coordinate the effort to the migration. But along the way, I think we were able to demonstrate some of the earlier success. We didn't try to do everything at the same time. We try to use the platform in a couple of places, and at least we're able to demonstrate the technical soundness of the platform as well as the benefit of those applications. And that sort of convinced the management so that we can continue with the full-fledged deployment of this new infrastructure.
All right. Thank you very much. That is really intriguing. So I'd like to thank you again for joining us so early in the morning. And thank you, Jun.
Yeah.
Have a good day.
Yeah, thanks everyone for inviting me.
Thanks.
Take care. Bye-bye.